Hey everyone, I'm Jamie Batts, your instructor for A&P2. We're going to continue on with this chapter on the reproductive system. In the last section, we were talking about the composition of the seminiferous tubules and how sperm formed inside of them with those nurse cells kind of holding it all together. Now we're going to start looking at how the sperm are activated in the male and female reproductive tracts. I know, right? It's kind of strange. How that works. We'll look more closely at it right now. Switch over screen share mode. Here we go. So the sperm are released from the testes, actually out of the epididymis, and they are not mobile. So we think of these sperm as little swimmers, but they're not actually swimming or capable of swimming until they reach the female reproductive tract. So the other parts along the journey of getting the sperm out of the male reproductive tract are going to help nourish and transport it out of the male body and into the female body. So this process is called capacitation. Capacitation happens in two steps. First, they're going to become better swimmers. They're going to become capable of propelling themselves, I should say, once they're mixed with the seminal secretion. So the seminal glands release special, it's like a fructose-sucrose mix. It's like a sugary compound to help these sperm become able to swim and propel themselves. And then they become capable of actually fertilizing when they are inside of the female reproductive tract. So there's two parts. That epididymis is the start of this journey. So the sperm's made in those seminiferous tubules and are kind of in this holding tank of the epididymis. This very coiled tube lined with pseudostratified ciliated columnar epithelium, and this is where they undergo their functional maturation. They finish all of the basic anatomy, and they basically get everything ready, but they're not swimming yet, as I said. The epididymis itself has a region called the head, the body, and the tail. The head's the region that's actually receiving the spermatozoa from the ductules of the seminiferous tubules, and then the tail is where the spermatozoa leave to go into the Ductus Deferens. There you see, again, it's still highly coiled, just like the seminiferous tubules themselves. You can see in that micrograph view the stereocilia on top of the columnar cells. So that Ductus Deferens passes through that inguinal canal with the spermatic cord with all the vessels and nerve endings and lymphatics, transporting that sperm to from the epididymis. It can store the spermatozoa for a while. They're kind of like suspended in terms of development and capacitation, and then the expanded end of the Ductus Deferens is called the ampulla, and that enters into the ejaculatory duct, which is carrying the fluid from the seminal gland into the urethra. So here you see this whole anatomy put together. The Ductus Deferens is a posterior view from behind the bladder. You can see the ureters coming down, the Ductus Deferens wrapping around behind that. The ampulla are these swollen areas at the end of the Ductus Deferens. This is where the spermatozoa can be kind of held for a long period of time. The seminal glands themselves, one for each side, and the ejaculatory duct is just the small passageway from those seminal glands and Ductus Deferens into the first part of the urethra, which is called the prostatic urethra because it's located within the prostate gland itself. Here you can see the prostate, which is that little, almost looks like a heart-shaped structure. And then there is another set of glands just below the prostate gland. They're called bulbourethral glands. We'll look at what those do in a little bit. So there's a cross-section of the Ductus Deferens. They have lots of cilia in them, kind of passing along the sperm. It's very similar, you'll see, to the female reproductive tract where we have cilia along the uterine tubes or fallopian tubes. Let's talk about the constitution of semen itself. So not only is it the spermatozoa, but it's the seminal fluid as well. It's a combination of the seminal gland secretions, the nurse cells, the secretions from the epididymis, secretions from the prostate gland, and secretions from the bulbourethral glands. So let's look at what these seminal glands are releasing. So the seminal glands are basically creating a secretion that is going to help in the first step of capacitation, helping them become motile. So up until the point where the sperm, before they meet the seminal glands, they are no longer, they're not capable of swimming, but after these secretions, they're able to swim. This is the majority of semen volume is from the seminal glands. Here you see just a cross section, all those little secretory pockets, just like a typical gland, right? The prostate gland is a more muscular gland. It encircles the urethra as it leaves the bladder and as it leaves the ejaculatory duct. There's lots of glandular tissue that wraps around this proximal urethra, which is also called the prostatic urethra. We'll see that in a second. This is a much smaller proportion of the semen volume, and it contains something called seminal plasma, which is actually an antibiotic that helps fight infections in males because the male urinary tract is much longer, and so this is basically just helping to keep the bacteria growth down in that longer urethra. The bulbourethral glands, which are also called the Calpers glands, these are located at the base of the penis, just near the urogenital diaphragm, and they have secretions that go right into the urethra. It's more of a thick, alkaline, mucousy discharge, which helps to neutralize any leftover acids in the urethra. Because the urethra is a dual passageway for both urine and semen, the bulbourethral glands, I don't know, I have a weird way of thinking about things. They're kind of like the street sweepers before the parade, so to speak. So they're going to come out before the rest of the semen just to make sure there's no urine to neutralize it and protect the sperm before they're released. So there you see those bulbourethral glands, lots of mucus secretions, as well as smooth muscle to help with the release of those secretions. You can pause the video here, go back and review this section. Let's talk about the penis. It conducts urine to the outside as well as semen. And let's take a look at how it is put together. The root is the fixed portion. The body is also known as the shaft, and then the neck is the narrow portion between the shaft and the glands. So the glands is the expanded tip of the penis, and the prepuce or the foreskin is the fold of skin that surrounds the tip of the penis. It is there to basically produce more secretions. A waxy material called smegma is released just to help lubricate and protect the tip of the penis from drying out. There you see all of the parts we just went over. You can see the inner constituents of the penis as well. There's two different types of tissues in there. One's called the corpus spongiosum. One's called the corpora cavernosa. Those are different types of tissue that we're going to get into in just a second, but I just wanted to point those out to you. This is just a different view, so you can see all of the male reproductive system together in like a nice frontal section. So you see all the way down from the testes and the epididymis. You can see that spermatic cord and ductus deferens wrapping up and behind the bladder, which is not in this picture. The seminal glands and the ejaculatory duct, which isn't labeled on this, but it's there. And then you see the prostate gland. The urethra is now the tube that's taking everything out, and the part of the urethra which is in the prostate is called the prostatic urethra. And then as the urethra passes through the urogenital diaphragm, it's called the membranous urethra, and then it is called the, is it even labeled on here? It's called the spongy urethra for the rest of the journey, but it's not labeled on this diagram for some reason. And then you see all of the parts of the penis, the root, the shaft, the glands, and the external urethral orifice. This one calls it the penile urethra. Okay, different textbook calls it different things. So there are different tissue layers to the penis, as I started to mention before. The outer skin resembles the skin of the scrotum. Underlining a relar connective tissue allows the skin to move without distorting anything below it, just like our normal epithelial tissue. And then the elastic tissue it encircles all of the internal structures of the penis. There is erectile tissue inside the penis, obviously, right? Three-dimensional network, all these vascular spaces and openings for blood to kind of be contained during an erection. And the resting state, the branches of the arteries are constricted, and then the muscular partitions maintain tensity, basically restricting the blood flow into the erectile tissue. The corpora cavernosa is the larger cylindrical masses, which are both on the front and the back side of the penis. And then the corpora spongiosum is surrounding the urethra itself, and it helps to keep that urethra open during an erection so that ejaculation can occur. So there you see the corpora cavernosum and then the spongiosum, which is just surrounding the urethra. All right, so there are different phases of a male sexual response. You have arousal. This is it's a sympathetic response, and this is as the penis becomes erect. So this is basically based on nitric oxide, that is the neurotransmitter working in response here, causing that arterial dilation, that vaso dilation that's going to occur to cause an erection. And the bulbourethral glands in this case are then squeezed to release their street sweepers, so to speak, to help lubricate the tip of the penis. Then you have emission, which is sympathetic activation. It begins with peristalsis at the ampulla within the ductus deferens, and that's basically pushing the spermatozoa into the prostatic urethra, and several series of contractions occur to get the seminal glands and prostate glands secreting, and those glands mix with the sperm to form semen. And then finally ejaculation, which is, doesn't say it on here, it's actually parasympathetic. It's a rhythmic muscular contraction, and it's controlled by motor neurons in the lower lumbar and sacral segments. And that is just reading off the slide to make sure I got everything. Yeah, there's just different muscles that are pushing. You don't need to know the names of those muscles, which is why I skipped over them. So there is some issues that can occur with erections or impotence in males. This is the inability to either achieve or maintain an erection. This could be caused by vascular issues like low blood pressure or interference with any of the nervous system commands, as well as psychological factors like depression and anxiety. So there are different medications like Viagra and Cialis, which are meant to inactivate any opposing enzymes that break down nitric oxide. So it's just meant to allow nitric oxide to be present to allow for that vasodilation to occur. Small amounts of nitric oxide can produce the erection. I keep looking because my kids are here. I'm like, are they going to come and listen to me talking about erections? You can pause the video here and go back and review this section. Let's keep moving forward with the male reproductive tract. Talk about hormones. So the hypothalamus is our main hormone releasing center in our brain, of course, secreting GnRH, which is gonadotropin releasing hormone. This is going to target the pituitary gland. The pituitary gland is then going to respond by releasing either LH or FSH, or a combination of both. LH is a luteinizing hormone. FSH is follicle stimulating hormone. You may remember these guys from back in our, can't remember what chapter number it is, the endocrine chapter at the end of last semester. So let's take a look more closely at what LH does. Luteinizing hormone is targeting the interstitial cells of the testes to secrete testosterone and other androgens that are needed. Testosterone levels are regulated by a negative feedback loop. When there's high testosterone levels, GnRH is going to be inhibited, and therefore LH secretion will be inhibited as well. FSH is targeting the nurse cells. The nurse cells are promoting spermatogenesis and spermiogenesis. They secrete ABP, androgen binding protein, to stimulate the spermatids to develop, and they also secrete inhibin. Inhibin is going to inhibit FSH. So you only need small quantities of FSH, and GnRH will be released, FSH will be released. FSH being released will then inhibit the release of FSH. So the presence of FSH turns off the pituitary from releasing more. So there's a feedback to control the rate of sperm development. So testosterone fuels sperm development, but so does FSH. Here are the feedback loops. The information is mostly involving regulating the hypothalamus. The hypothalamus being the main control center. The hypothalamus will send signals to the pituitary to either shut off or increase the production of LH or FSH. Inhibin directly inhibits FSH from the pituitary, but it can also inhibit GnRH as well. So let's talk about some of the peripheral effects of testosterone. So other than just fueling sperm development, it also maintains sexual drive and other sexually related behaviors. It can stimulate bone and muscle growth, which is why men tend to have a larger stature, more muscles than women. It can also establish and maintain all of the secondary sex characteristics that are related to being male, like being hairier, having a deeper voice, overall body shape and composition, things like that. Can also maintain accessory glands and organs of the male reproductive tract, like the prostate and the seminal glands and things like that. So there you see peripheral effects of testosterone. It has an effect on the central nervous system, bone and muscle, maintenance of all of the secondary sex characteristics, which are all listed there. I think I hit all of those, except the distribution of fat deposits or adipose deposits, which tend to develop in different places than on females, and then all of the accessory glands, as we noted already. So let's talk about DHT, or dihydrotestosterone. DHT is a special form of testosterone that the testosterone itself is converted to in some tissues. This is a small percentage of the circulating testosterone in males and females that it can bind to the same receptors as testosterone itself. Some receptors or some tissues are going to respond to DHT instead of just straight testosterone, like the external genitalia. So other tissues are more sensitive to DHT than others. Like the prostate gland, for example. So you have to have decent levels of testosterone in order to have fully functional external genitalia and prostate. You can pause the video here. Actually, you know what? I'm going to stop the video here because coming up is the female reproductive system. And you can let me know what questions you have about this section. I'm going to stop screen share. There we go. Have a great day. Bye.